So just remarks on this exercise that we've been undergoing. Often in models, there's many processes going on within these dynamic models that represent general underlying aspects of the world. But then we also frequently layer atop the models what I call epiphenomenal processes, processes that observe the model but don't affect its operation. And these sort of reporting processes can be as simple as adding a pie chart that knows how to update itself periodically, or a time plot, but in some cases it will involve more mechanism as well. And just like for a real-world population where we can collect information of certain sorts, we can collect sometimes comparable information from these types of model populations. We can readily aggregate up and maintain information on metrics for when an individual underwent certain types of underlying health states. A very important point about these sorts of models when compared to real-world populations is within these models we have what might be called a God's eye view of the situation. We know exactly what's going on within the model at any one time. We could have it report what's going on in however level of detail is needed. And that provides us a way, an avenue for testing out, for example, ways of measuring things to identify which metrics, which proxies or surrogates for underlying state are more accurate than others. We can apply it to our model population because we know the underlying ground truth, the underlying true situation. We can evaluate the information we get from proxy measurements with underlying measurements. So I do a lot of work, for example, with provincial databases. Like Australia, Canada is a single payee system for healthcare. And so we have, like in Australia, population-wide administrative data, although on a province-by-province basis. And using that data, there's often administrative algorithms put into place for how to best identify cases of diabetes or cases of gestational diabetes or cases of osteoarthritis. And you can have a model which simulates underlying health states of a population. And even if that model isn't a perfect mirror of things in the world, and it will never be a perfect mirror, it may help by experimenting in the model with different surrogate measures, different proxy measures. You can evaluate how those stack up against the underlying ground truth and use them to identify blind spots associated with certain of these measures, okay? So within these models, this reporting that we've been doing here, well, it's just been a small start, as befits a four-day experience here. It's a type of process we very commonly include in models, and which can form a key part of scientific investigation with models. But before we go on, I wanted to address a question I got from Matthew, and specifically, I wanted to push the limits of what we're on what we're collecting data, ladies and gentlemen. So thus far, what we've been doing is we've been summarizing information about the population using statistics. This is an AnyLogic construct. These statistics have been defined in the population. So for the population, we defined statistics here. And those, I argued, gave a cross-sectional view of the population. They were updated over time, but they weren't following, these statistics were sort of summarizing up about the population. They weren't following any particular person, and they certainly weren't yet following incident cases, the incidence, for example, of diabetes within a certain time. It was just the prevalence they were reporting on. So we have many types of vistas we could explore with reporting. And if I had my druthers in the time, right now I'd use the next time till lunch to do just that. But we want to get on to discrete event modeling. So what I'm going to put into place is a mechanism that will allow us to examine some information about a person's history. And later, we'll try to hit on incidents, reporting incidents, okay? So, ladies and gentlemen, I would like you to go to double-click on person, okay? And within person, we're going to be looking at these transitions here. And what I'd like to do is I'd like to put in place a mechanism to record the age at which someone became obese, first became obese, and the age at which they developed diabetes. Okay? We're going to look at these two mechanisms. Okay? So, ladies and gentlemen, this is not something which we can undertake immediately using a statistic that we define. There's no statistic for immediately computing this. We're going to need to put in place some additional mechanism to do this, okay? And the first one I'd like to start with, because it's a little bit simpler, is to record when they became diabetic, okay? So, ladies and gentlemen, I'd like to go to the palette. Oops, I just dragged my palette there. I'd like to go to the palette, and I'd like to drag in a variable. Okay? Yeah, I'm just thinking in terms of time. Yeah, it'll be a little bit faster to actually do incidents. Maybe I will do incidents now, and we'll leave the other one till later. So, excuse me. This will be called. We'll actually drag a variable. I'm going to change my plan here slightly. We're going to drag a variable into main instead of into person. Okay? It'll be a little bit simpler. We'll let us get onto discrete event model a little bit sooner. So next that we're going to go to main, and we're going to add a variable into population that will be called incident case count of diabetes for year. Okay, that's a long name, and remember, autocomplete is your friend. Okay, incident case count of diabetes for year. Okay, yes, we could change it. Maybe we want to change it diabetes incidence case count for a year. But let's just leave it like this for now, okay? Incident case count of diabetes for a year. Are we okay with that? Because we could have an incident case count of obesity for a year. Incident case count of diabetes for a year. Now, this is going to be a count. So what sort of type would it be? Is this going to be a double? Is it going to be a person? Is it going to be a sex? It's an integer indeed. It's an integer. And its initial value will be 0. We're going to start out at the beginning of a year. Okay? Its initial value will be 0. Okay. So, ladies and gentlemen, under what condition will this variable rise? Can anyone tell me? Someone changing into a diabetic state. So where would we find that logic in the model? It's in person. So we're going to go to this transition here. Alternatively, we could have gone to the entry action, but there's only one transition here, and I'd like to associate it with that. So we're going to go to that transition. I'm going to show you something you haven't seen before. There's an action associated with each transition. We're going to use that. We glimpsed it yesterday, but we're going to use it here. So the action associated with this transition, really I should name this transition, it's becoming diabetic, and maybe I'll do show name, so it's placed here. Okay? Becoming diabetic. The action here, ladies and gentlemen, will be to increase that variable. Make it 1 bigger than its value was. Okay? Are we okay with that? Okay. So the action undertaken when this transition occurs, the action will be fired. The action will occur. So we're going to need to give it an action that increments that variable by 1. Okay? Now, I'm going to do this here. So that variable, if I said incident case count of, don't do this, of diabetes by year, if I did this, it's not going to know where to look for it. Why not? If I said this equals this plus 1, it's not going to actually find it. It's going to be an unhappy camper. What do you think it will? Ooh, especially because I misspelled it. I'm misspelling because for reasons I'll show you, I can't do an autocomplete there. It says it can't find it. Why not? Where does that variable live?
It's in Maine.
It's in Maine. I can't just say it here. I have to tell it it's in Maine. It's not in this. It's not this. It's not in me. It's in Maine. It's not in each person. It's in Maine. So if I did this, and then I could say incident case count. I don't have to actually retype it, but redo it. But I just thought I'd do it in case I misspelled it. Okay. It's still okay. I must have misspelled the second one. Okay. Incident case count of diabetes per year. Okay. So this is what I put down here. Now. This is true. It's a little bit wordy. We have to kind of look. Sometimes when we look at this, is this one on the right the same as the one on the left? You can do it. We're just making it 1 bigger than its original value. It has an original value. We add 1 to it, and we assign it to itself. But you will find there's a way to do this very crisply, very succinctly. What Dylan's generation would say very sweetly. And that is to use something from Java that its job in life is just incremented by 1. It's plus plus. That means the same thing as that. Now you can use whichever one makes you feel more comfortable. I will just tell you that in the example models you see from me, you'll occasionally see this plus plus. And all it means is make it 1 bigger than it was. That's all it means. And it's to the point. You don't have to kind of look, is the one on the left the same as the one on the right to understand it? You don't have to have this plus 1. It just means make it 1 bigger than it was. Okay? So I'm going to put that there. But you may wish to instead put this in. And I will hold you no grudge for doing that. I think that's perfectly good. And in fact, in my boot camps, I'll go back and forth on this issue. Because I feel a certain amount of guilt teaching you jargon. But I am aware that the health sciences are not devoid of jargon. In fact, I believe both computer science and the health sciences, particularly medicine, vie for the crown of the most acronyms in any given field. What's further distressing is that the same acronyms are used in very different contexts by the different fields. And sometime in the course of a day, I go from a discussion in one field to the other. And a term such as STIs, which in software engineering means system trouble incidents, ends up being used in a very different context a few hours later. And the transition is sometimes abrupt. Okay, so I would like to build this model. And we're still not done. Let's go see what happens when we run this model, okay? Let's go run it. And then I'm going to introduce something you haven't seen before, which will serve as another motivation for doing it this way. So ladies and gentlemen, notice there's this incidence case count for diabetes for a year. And it says for a year, but right now it's going up year to year and year, and it's just increasing year after year, right? In fact, if we click on it, this is a useful thing. If you click on it and you do this, you can actually see a graph of how this is changing over time. How did I do that? Ladies and gentlemen, I clicked on this, I dragged it a little bit, and then I click on this, and I can actually see a graph of it, okay? Okay. So that's the cumulative incident case count. That's a cumulative count of cases that have yet occurred. now I want to make it for this year. I just want to see it for this year. Each successive year, I want to know how many occurred in this year versus next versus next. So this is really serving as the cumulative case count, right? That's what that is. It's a cumulative case count. I would like to modify it to be the case count for this year. Okay. So how would I do that? Well, think about how it's done in the real world. I mean, you count up, and then on, conceptually at the strike of midnight on December 31st, you zero it out, right? Maybe you report it and you zero it out. What do you think? What do you think? Yeah. Okay, so ladies and gentlemen, I'd like to go back to Maine, and I'd like to put a similar mechanism in place here. But I'd like to add an additional construct that will be your friend. Okay? I know, you're getting many friends this boot camp. Human and computational. Okay, ladies and gentlemen, I'd like to go to the palette, and I'd like you to go to the analysis part of the palette. And there will lie a data set. Okay? And I'd like to drag in the data set. And this data set will be called diabetes incident case count. Diabetes annual incidence case count. Data set. Okay? I don't like to leave a lot to the imagination.
Just a question.
Yeah.
If you now update the name of any variable, will that automatically update in anywhere you've referenced it?
If you do it in the right way, yes. So if you wanted to change the name and you wanted everything that counts on this name to be changed, there's a way to do that in AnyLogic. And the way to do it in AnyLogic, I won't do it, but I will. Maybe I'll do it to show it to you, just so you see how it's done. People don't have to do this, but if you'd like to do it, okay. Suppose I critique this name and I say, look, it could be a bit shorter. I'll call it diabetes incidence, diabetes annual incident case count. Annual incident case count. Okay. That's what I want to rename it to. Now, you notice when I'm doing this, there's this little thing here, this little light bulb, and it says press Control-Enter to perform refactoring, to replace name occurrences. If I press Control-Enter, before leaving this, if I press Control-Enter, it'll actually be searching for all references to it. Everywhere that counts on this, it will find. And it's going to ask me, should I change it in this place from that to that? I'm going to say okay. And now it's changed it, okay? And now if I build it, it's a happy camper because I've changed not only the name of the variable, I've changed everything else it depends on which it depends. Excuse me, everything else that depends on it, I should have said, okay?
It's Control and Enter.
Control plus, yeah, Control and you hold down Control and you press Enter. On Macs, Dylan, on Macs,
Option,
yeah.
The tooltip should actually say.
The tooltip should say Command Enter. Thank you. Okay. Okay, ladies and gentlemen. Just making sure that's recording. Okay. So okay. Okay, there's something funny going on. Okay, we have this data set. Ladies and gentlemen, I'd like you to change the data set to keep up to 1,000 latest samples. And it should be do not update data automatically. Okay? Great. This is great. Okay, now this is what we want to do. We want to, every December 31st, we want to zero this count off, clean the slate for the next year. And we want to take whatever value was here and save it into the data set. That's what we're going to do. Are you ready for this? Okay. So the final thing, which will be a point of learning, draws us back to the analysis palette, and you will drag in what's called an event. And this will be called yearly reporting event. It'll go off every year at the beginning of the year. An event really, in AnyLogic, what's called an event, it's a misnomer. It's actually an event schedule for the most part. It schedules events, one or more. And this event schedule, in its properties, it will be not a trigger type timeout. Excuse me. It will be a timeout, but it'll be not occurring once. It'll be occurring cyclically every 1 year. Are we okay with that? And its job, the job of this event, is to fire off and do something. That's what its job in life is. It's to actually do something every time it fires. At the beginning of the year, what's it going to do? Well, it's going to do two things. It's going to take whatever value's been accumulated over the past year and report it to the data set. And then it's going to clear out that value. Are we okay with that? Okay. Now, there's just one fly in the ointment that I'll come back to. But for now, we'll leave this as it is, and we'll write the code. Okay? Okay, so here we go. So the first thing we're going to do, before we stomp on the value, before we set it to 0, we need to save it away. We need to put it to the data set. After all, we've been accumulating these values for the past year. We need to save the value away that we've accumulated for the past year. So to do that, ladies and gentlemen, okay, for this, we're going to do the following. This dot, we're going to name the data set, dot, so saying, okay, the data, so in me, consider the data set. And for that data set, do, and I'm going to say add whatever value is in this variable now. So whatever value we've accumulated over the past year, that's the one that we're going to put in the data set. And it's going to be diabetes case count, not the data set here. We're adding it to the data set. So let me put it up here. That's what we're doing. To this data set, we are adding the value of the variable. Oh, sorry, this should really be, this, if we want to be consistent, this dot diabetes incident case count. It's in me. Okay. Okay. So this is what we should do. Now this incidence case count variable that we had added, this was the integer that was 0.
Why is this and not main?
Okay. Yeah, we're currently in main right now. We're located inside of main, so this is actually referring to main. When we're in person, if there's something that lives in main, we need to say main. But if we're already in main, we just refer to ourselves because it's here, it's local. Okay? Okay, so how did I do this? Yes, Dylan?
Can you put that up on the big screen?
I did
Oh,
here.
okay.
So to my data set, I am adding a value. What is this value? It's given by the value of this variable. Are we okay with that? That's the first thing I'm doing. Okay? The second thing I'm doing is clearing that variable, setting it to 0. Okay? So the second thing I'll be doing is this. Taking the variable, taking this variable, this whole thing, and setting it equal to 0 like that. Okay? So I've added the current value of the variable to the data set. This variable has been added to every time someone became diabetic in the past year. I've been incrementing this variable, make it 1 bigger. It's been accumulating. I record away the value, and as January 1st dawns or starts, I'm zeroing it out for the next year. Okay? And that's it. Are we ready for that? Okay. So, ladies and gentlemen, that's good. Let's run this model and let's observe the results. Okay? So mumble here. Sorry. Let me go. There we are. Okay. Great. There we go. Okay. Yearly reporting event. Okay. Oh, there's one fly in the ointment. I forgot to tell you. Well, we'll see it. It's better. I'll let you. Okay, this sounds cruel, but I'll let you be burnt by it, and then it'll make it clear why we need to fix it. Okay? Okay. I'm going to save this model. Hey. Okay? Save it. I clicked on this and saved. And now let's run it. Ready? I'm going to run it for the big population. Here we go. Run. And here it is. It's sampling it. And year 0, it says 0. Year 1, 6. Year 2, 13. Year 3, 20. Year 4, 24. This is the incident case count. Notice that we can graph this if we want to do so. This is the incidence case count per year, and it is rising right now, but the population is only of such a size, it's going to have to eventually plateau out and then probably decrease, because you can only have so many people getting it out of the total population. So it's here, it's plateauing out, and now the incidence case count. Okay, okay, this is okay. Mumble. Okay, so I thought we set it to 0. Did I not set it to 0? Okay, so something is not working as I expected. Okay, so let me. Oh, I didn't copy that line. I've just put it up on the big screen. I didn't actually copy it here. Sorry. Sorry, folks. I messed up there. I put it up here, but I forgot to copy it to the model. Okay, here we go. Run. There we go. Let's give this a try. And I'm going to run it here, and I'm going to go click on this, and I'm going to display it. And you could see that it's sort of hitting around here on a per year basis, and eventually it's going to start decreasing because there's fewer and fewer people who can still become diabetic. Okay, great. Okay, so ladies and gentlemen, there's one fly in the ointment. You notice that for year 0, the value is 0. Why is that? Well, this thing went off at year 0, and it recorded the value to the data set, even though there was no one yet who could have possibly become diabetic before this time. So this goes off at time 0. Let's have it start at time 1. It starts 1 year into the model to record the value for the first year. Now how did I do that? I went to the yearly reporting event, and I set for the first occurrence time, I set it to be 1 year. Okay? Are we okay for that? Okay, now let's run that, and now we will see that we're no longer have to suffer that blemish. It's now the first year is properly recorded. So the problem was, ladies and gentlemen, that it was going off at the very start of the model, when of course there was no one who got diabetes yet, and it was recording its value away to that data set. We don't need that. It's not providing any significant information. So what we wanted to do is to have it start at 1 year in, and from then on go every year. Okay, so this was an incident case count, and involved a little bit of mechanism. Later we'll come back and do some things longitudinally on a person, which are on the same order of magnitude. Okay, of difficulty. Okay, ladies and gentlemen, are there any questions about that before we go on? Yes.
Not quite sure why you're using a database and not a variable. Why don't you set up another variable?
Oh, a data set? It's because, that's a great question. So this data set is accumulating values that I might export, for example. Whereas if it were just a variable, it's only going to remember one number.
Oh, I see, so they're all there.
They're all there.
Uh-huh.
So if I run this, for example, you folks don't have to do this, but I pressed the wrong button. This is the debugging interface, but that's fine. It'll serve just as well for this. So it's running here, and if I went here, for example, first of all, I could construct a plot based on this. Okay,
Yeah.
I could have it plot that out. Another thing I could do is I could do copy here, and I can go over into Excel, and I could create a new sheet, and I could copy down the values. So it's storing all these values historically.
Whereas if it was a variable, it would just have whatever the most recent
The latest one, yeah. Unless it was a special type of variable called a collection, in which case it's basically doing what we're doing with the data set. But the data set is clear. I will show you another thing, although I won't do it. If we have a, if we go back to this and we were to go consider a chart here, these charts, you notice going back, they can depend on a value or a data set. So we could have it just directly plot out this. Well, okay, maybe we should do that. Okay, so ladies and gentlemen, if you'd like to follow along, if you go to the palette, let's add one more chart. Where do charts live in the palette? Anyone remember? Where does a chart live in the palette? In the analysis area. So we're going to go to the palette. We're going to add one more chart to this. It's going to be a time plot. We will enlarge it, and its name will be diabetes incident case count plot. Its data, in the data items, we will have it plot the data set that we just created, and we'll call it diabetes incident case count, and it will be diabetes data set that we're going to put here, the data set. Is that okay? And I can tell it, yeah, display up to 100 samples or 1,000 samples. Okay, diabetes incidence case count. The difference here is before, when we had graphs, we were, watch this. Here I'm displaying this data set, whereas before, when we did this, we were displaying values, particular values. With the data set, we're going to display this whole data set, and it'll be this historic data set. Now, there's another way to do this, which would just use values. It's a little bit less mechanism. With the data set, we could save it away to Excel. It's easy. And you could argue as to which is best, but I'm going to prefer doing it this way. And ladies and gentlemen, so we added this, and now if we run this, we find that we could create a nice plot up here, up at the top. Whoop. Hey, oh man. Here we are. Here's the incident case count over time, and this thing is kind of the interesting thing is it's okay. There's an I detect a fly in the ointment. Okay. Okay. Dylan and Annie, help me think this through. Why would that have changed suddenly? Okay, there's something which I'm. Okay, you're gonna have to let me think this through. This on my feet or my. So why are we suddenly having zeros in here, in such perfect sequence? It's updating twice. Okay, it's updating twice. So it must be updating because this thing has been now updating. Okay. I bet it's doing that. I remember that from my youth. Well, or at least from 3 or 4 years ago. Okay, yeah. Yeah, now we're hunky-dory. Okay, so ladies and gentlemen, that's confusing. Man, I don't like that. But AnyLogic didn't ask my opinion on that one.
So what did you do? What did you
Okay, so we had been, we had a scheme which worked fine. We added this data set. Sorry, this chart. And this chart depended on the data set. Depends on this data set, and it calls it accordingly. I set it to display up to 1,000 samples. And I thought things were fine. Because after all, adding a chart to observe the data set shouldn't change the data set. But I was wrong. And in the questionable wisdom that AnyLogic has implemented this, because the chart was being updated automatically, it also updated the data set at those times. Which, Dylan, are you hearing this? That's bizarre. It shouldn't update the data set. So I changed this to not update automatically, and we're in fine shape. So basically, if it's updating automatically, it goes and tries to update the data set, it seems, with a value, which is just weird. And all I'm saying is, if it's depending on a data set that's being updated through other mechanisms, you turn that off and you'll be fine. And so now it's a happy camper. Now it's doing this fine. But yeah, I remember that from several years ago, and at that time it was also a little bit strange. But in any case, so how did I fix that? I went to the time plot and I turned off this update data automatically. Are we okay with that? Okay. So, ladies and gentlemen, I would like to close this model. We are done with this little bit of reporting, both using statistics, which can be declared declaratively, which can be specified declaratively. With statistics, you didn't have to write any code. All you had to do was give a formula for what you wanted it to count and say you wanted it to count it. And then we added something which did require a wee bit of code. We added a reporting for incidence case count where we had to increment a variable in main this way. And then up in main, we not only had to, I should say down main, we not only had to maintain this variable, have this variable here, but we added a data set, and this data set was then used by an event. Every January 1st, it added a value to the data set, and it set its current value to 0. Okay? Okay, that's it. Okay, so I'd like you to close that, and I'd like to move on to discrete event modeling. Yes?
So a quick question. What exactly is the keep up to 1,000 latest samples doing?
Okay, that's a very good question. Chris, is it?
Yeah.
Yeah. So one of the balances AnyLogic has needed to strike as a product is a balance familiar to other software engineers such as Dylan and myself, and that is you need to, you want to provide as richly a functional product as possible. You need to take into account that computers that people run on have limited resources, okay? Limited memory, particularly limited processing speed, etc. And one of the ways that AnyLogic has tried to take this into account, to their credit, is by having, by securing economies in terms of storing data. And one of the ways to do that is, throw away old data items if they're not needed. So if you're only going to need the most recent 10, why store all more than that? And so AnyLogic provides you, whether it's with this data set or whether it's with a chart. You notice for this data set it says keep up to. With the chart, this time plot, there was a similar thing here, display up to 1,000 samples. Basically, it doesn't want to be saving away values you don't care about. So it provides you a way, very helpfully, I think, of saying, how far back do you care? And, in some cases you might say only 10, right? But my own critique of it is, in my work, 100 is rarely enough for us to show. Maybe we're doing monthly cases of, pertussis, and we're doing so over a span of 20 years or 30 years. And so then we might have 360 samples. And rarely is 100 the default enough. So that's why I changed it to 1,000, just because I don't want it to be truncating the data set in a peremptory way during our experimentation. And I find that 100 is rarely enough for a lot of my models. It's perfectly reasonable to have that choice. It's just 100 seems to me a little bit small. And I frankly think at that point, the economies that you're getting, the difference between 100 and 1,000 data points is pretty modest computationally. So I'd prefer if they had a default of 1,000 or something. And there you're starting to get into somewhat more serious savings. But anyway, that's what that is. Is that helpful?
Yep, thank you.
Okay. Any other questions? Okay. So let's stop the model. Let's close this. I will, as I am wont, post that to our site. And now we will go on, ladies and gentlemen, to describe